Hi there! Did you know that only 3% of the water on the planet is fresh water? Yeah, most of this water is isolated in ice caps and is decreasing as we speak. So we, as engineers, have decided to get involved to increase that percentage. The grand challenge is to provide access to those unfortunate countries who do not have abundant sources of water and restore the world's freshwater resources. Another part of the grand challenge is also to limit where we use the fresh water, since it's not abundant. By doing this, we should be able to increase the percentage of fresh water so that our future generations will have plenty of it all around the world. The first step of many steps is knowing where their country as well as themselves stand when using the limited water resources. The goal of our program is to act as a stepping stone needed to have a global impact in providing access to clean water. By providing users with information about how much water various countries have versus how much they use and in which areas, they will know if and where they need to limit water use. Our code serves as a wake-up call to a serious problem, and the sooner others know if they are contributing to the water crisis, the sooner they can change. One of two parts of our code is to inform the user of the total amount of fresh water their selected country has, as well as the areas where the most water is being used. These areas are broken down into three categories: agriculture, industrial, and domestic. During this first part, we also show the user how their selected country is doing, using water footprints. These footprints are broken into three different colors: blue, green, and gray, which are set into a range. The user also has the opportunity to display up to two countries. If they do decide to display two countries, they get the chance to compare how much more water one country saves compared to the other. Part 2 of our code allows the user to compare their water use versus the average person's. We execute this by asking the user a set of questions about their water use, such as how long do you take in the shower, how many loads of laundry you do per week, etc. Once the user has inputted values for those questions, we add up all of those values to compare data of the daily water use of an average person's. Hold that thought. Refreshing. Now let's take a closer look at the code. This is our code. In our code, we have included things such as the problem statement, input variables, output variables, housekeeping commands, and setting the input variables. The problem statement is to calculate the water footprint of the selected country. Based on the calculations, an image will display with the color footprint. If two countries have been inputted, they will be compared by their water use. The user will be prompted to input their usage values and will be presented with their water usage and whether or not they are contributing to the water shortage. Our input variables all represent part 2 of our code when we ask the user about the way they use water every day. Our output variables represent the two different parts of our code. This first variable, color, stores the image we will be showing the user about their footprint. When we set our input variables, we first load the data. Then we find the size for later reference. At the beginning, when writing our code, we noticed that it will be easier to store every single column of the data into different variables for easy indexing. So we created a different variable for each column of the of the data set that we have, which is all of these right here. As you can see, we have two different datas. So we load the second one as well. And as I mentioned earlier, we will be showing the user an image with their footprint of the selected country. So we have to load the images as well. Since these images are all different sizes, we have to resize all of the images. So that's what we do on this side. We have created 3 different for loops. These for loops are used to combine 2 images that we will be using in part 1 of our code when illustrating the water footprint of the user selected country. This first loop is to combine the background image and the gray color footprint. This one will be for the background image and the green footprint. And this one right here will be for the background image and the blue footprint. Now we have part 1 of our code. We first ask the user to input a country. In order to make sure that the country the user has inputted, we created a while loop to check if this country is part of the list in our dataset. If the user has inputted a country that is not in our dataset, we have created a warning which will allow the user to enter a different country. Once the user has inputted a country that is in our dataset, we will calculate the water footprint of this country. If the user selected country is using less than 20% of the water, it will be considered a blue footprint. If it is using between 20 and 60, it will be a green footprint. Anything else above 60 will be considered a gray footprint. These conditional statements right here are to output the footprint of the user selected country. After displaying the water footprint of the selected country, we will ask the user if they would like to know how its country uses its water. If the water footprint is either green or gray, it will automatically show where the country uses its water. However, if the water footprint is blue, the user will have the choice to decide whether they would like to view it or not. At the end of this, we will give the user a second chance of viewing a different country. If the user selects yes, we will ask them to enter a new country. However, the user cannot exit out of this menu. We have created a while loop to make sure of this. If the user selects to view another country, we will ask the user to input a different country. We have done the same thing we did on the first part. We created a while loop to make sure that this country is part of our dataset. And if it's not, we will give them a warning telling them that this country is invalid and ask them to enter another country. We do the same thing with the footprints. We will show them the footprint of this selected country and we will show them the image, as you can see right here. This will be the last time they can view a country, so this menu will not really show. After the user select the country has outputted all of its values, we have created a statement where the user can see how much more water one country saves over the other one. However, if the user only decides to view one country, this output statement will not show. We have now started part 2 of our code, your average water use versus the average person's. In part 2, we will be asking the user a set of questions about the way they use water. In each question, we have created a while loop to make sure that the user inputs a number. Because if the user does not input a number, the code will not work. These are all the questions. How many baths do you take per week? How many showers do you take per day? Give an estimate of how many minutes you take per shower, an average of how many loads of laundry you do per week, how many times per day you flush a toilet, and so on. In all of those questions, the user must enter a value greater than 0. And this is limited in the while loop, as you can see right here. After those questions, converted from gallons to meter squares. In the dataset, there were 2 different units, gallons and meters per square. After the questions, we included the calculations. In our dataset, there were 2 different units, gallons and cubic meters. We have decided to convert all of those values to cubic meters, which is done in these. We also saved all of the inputted values from the questions into a matrix because we need to add all of those up to compare it to that of the average person's usage of water. This is the summation of all of those values. These 2 fprintfs state whether you use more water than that of the average person's or not. It all depends on the values the user inputs. These statements are conditional statements to be outputted into the command window depending on whether you use more water than the average person's or not. Like I said, it all depends on the numbers the user provides in there, in the questions. Now, that is all for our code. Now, let's run the code to take a look at the outputs. This is part 1 of our code. I will be typing in a country, and as you can tell, the United States is a blue color footprint, which means it uses less than 20% of its water. I would like to view another country, so I will be clicking yes. As you can tell, China is a green color footprint. And yes, I would like to view China's water usage. As you can tell, the code shows us the amount each country saves. Now we have started part 2 of our code. It will start asking us questions about the way we use water. It is asking me how many baths I take per week. Let's say I take 2. Showers, I will put 7 for every day of the week. I take 15 minutes in each shower. I'll do 2 laundries per week. I'll flush the toilet, I don't know, 3 times. I drink 5 cups of water. Let's say I wash dishes 2 times a day. 5 minutes. I don't do any farming, so I will be putting 0. The code is showing that I use way too much water compared to the average person's. And as you can tell, it is telling me right here that I use way too much water than that of the average person, and I am contributing to the water shortage. Well, this is our code. So now let's talk about how we can use this code in the future. This code will help future engineers determine which countries need help regarding access to clean water the most. Also, determine in which areas they need to have to limit water usage, such as in agriculture. Since most of our water goes toward agriculture, engineers will know to create new inventions and technologies that will help limit the water use in this area. Some limitations include things such as our dataset being that of current years and it being global. Another limitation is that our code is informational rather than providing an exact solution to the water shortage problem. Now, that's all we have for you today. Thanks for stopping by.